Hello, welcome to my channel, and here we are going to solve this problem. Though I've solved a problem like this before, but I have looked at the method that I used then. Though that method has its own use, and it's also very important that you learn that method. But now I want to solve this problem, and I want to apply two different methods to solve this particular problem. And according to what we have here, so we have the figure below shows two views of a triangular lamina in first angle projection, and this is the views that we are given. This is the plan, and this is the front elevation. Then the question now says that we should copy the given views. That is question A. Question B says we should construct the tree shape of the lamina, while question C says that we should measure and state the length of the three sides of the tree shape. Alright, so that is the question. But coming here now, we are asked to copy the given views. So we have the horizontal distances, and we also have that is horizontal dimensions. Then we also have vertical distances of vertical dimensions. So here we have point A here, this is point B, and this is point C. And looking at what we have here, so we have that the distance of point A from this horizontal line is 50 millimeters, and that of point B from the horizontal line is also 50 millimeters. That is 15 plus 35. While distance of point C from the horizontal line is 15 millimeters. So then coming up here, so this is also point A here, though it is not written. Then we have that the distance of this point A from the horizontal is 25. The distance of point B from the horizontal is 12, and distance of point C from the horizontal is 45. Those are the vertical distances or vertical dimensions. Then for the horizontal dimensions, we have that the distance of this point C from this point A here on this line is 25, and the distance of point C from point B on the horizontal is 45 millimeters. So we are going to make use of these dimensions, and then we reproduce the given view. So let's see how it goes. Now the first thing that we need to do here is for us to draw a horizontal line. So we draw a horizontal line here. So just look at how I'm going to do it. So we draw a horizontal line here as we see it in the diagram on the views that we are given. So we draw a horizontal line like this. Then with our ruler, so we are going to take a measurement. So we take the horizontal distances first. So this is the first point on the horizontal line. Then we take 25 millimeters. Then after that we take 45 millimeters. Okay, 45 millimeters. This is 45 millimeters. Okay, so this point here, I will just label this. I will label this point as 1. So this is where we have A. So this point 2, this is where we have C, and this point 3 is where we have what we have B. So I don't want to label it A, B, C, because we are still going to make use of the letters. Okay. Now what we are going to do here now is that we are going to erect vertical line on each of these points. So here we draw a vertical line. So we draw a vertical line like this here. Also, then here we come here, we draw a vertical line, and also at this point we draw a vertical line like this. Okay. So on these vertical lines, I'm going to take the vertical distances or vertical dimensions as we have in the drawing. So let's get that of A first. So A down from this line. So I'm going to call this line, I will call it XY line. So this is XY line. Okay. So A down the XY line is 50 millimeters. So I will take 50 millimeters down. And above the XY line it is 25. So that will be 75 millimeters. So here we have this point. Okay, so if I label this point, this is point A. Yeah, and then this is also point A. So I will call this A1. Okay, I call that A1. Then let's get point C. Let's get point C. So C from, or let me get B. So B, we have B here on this point 3 here. So it is 50 millimeters down XY line. So it is 50 millimeters. Then it is 12 millimeters above XY line. This is 12 millimeters. So at this point, so we have B at this point. So why at this point we have what? We have B prime. So we have B1, sorry. So B1. Then let's go for C. So C below the XY line is 15 millimeters. So I will take 15 millimeters. And above the XY line it is 45 millimeters. I will take 45 millimeters. X is 45 millimeters. So this is point C. Okay, and this point is C1. Okay, so now the next that we are going to do is to join the point together. So I will join AB together. So join AB together here like this. Then I will join AC together. Okay, so joining AC together like this. Then I will join CD together. So this is the first method that I want to use. Okay, then coming up here, so we also join AC together like this. A1, C1 together. Then we join B1, C1 together. B1, C1 together like this. Okay, then we join A1, B1 together. So we join them together like this. So we have drawn the given view as we are instructed. Now, let's go and work out how we can get the true shape as we are instructed, how we can get the true shape of the triangular lamina. So what we need to do first is that we come up here at point C, at this point C here. So we come up here and we draw horizontal line. We draw horizontal line. Okay, so having drawn this horizontal line, we take our compass. So we put the pinpoint of our compass at A here, at point A, and we extend it to point C. Okay, then we draw an arc. So we draw an arc from here. So this arc, so it touches our point. It touches this line AB at this point. So I will call this point, I will call it point Q. Okay, then I will put the pinpoint of my compass at B and extend it to C. Okay, so I extend it to C. Okay, and okay, before that, so when we put the pinpoint of our compass at A here and we extended it to point C, we drew this arc. So this point here, so what we are trying to do is that we want to locate the true length of AC. So we want to locate the true length of AC. That is what we are trying to do. So we want to locate the true length of AC. So what I did here, let me repeat it, is that I put the point of my compass here, I extend it to C, and I drew this arc, which meets line AB or side AB at this point Q here. So then what I need to do here is that I will set my set square at this point, so with the support of my T-square. So then I will draw a vertical line. Draw a vertical line. So wherever this vertical line meets this horizontal line, so I will call this point C. So C2. I will call it C2. So now then I'm going to draw a line from A1 to join C2. Okay. Alright, so this line A1C2 is the true length of AC. Is the true length of AC that we will use to produce the true shape that we are asked to produce. So I believe that is clear. Now, the next that we are going to do is that, so we take our compass and we put it at point B here. Okay. Then we extend it to point C. Okay. Then we draw an arc like this. So wherever it touches this line AB, so I will call it point P. So this is point P. The next that I'm going to do is that I will draw a vertical line from this point P here. So draw a vertical line from point P and it goes up to meet this horizontal line. Okay. So this point now I will call it point C3. So I will call it C3. Okay. So now I will draw a line from B1 to point C3. So this line B1 C3 is the true length of BC. Is the true length of BC. Now let's produce the true shape as we are asked to do that. So so what I'm going to do is that I'm going to produce it here, and what we need to do first is to withdraw a vertical line. So I will draw a vertical line. So like this here. I draw a vertical line here. Alright, so let me extend it a little bit. Okay, so we have this. Then I'm going to call this point here. So this point, so I will call it, this is point A, so we fix point A. So I will use small letter A for that. Then I want to get AB, so we still take this is the true length of AB. So we take this distance from here. So distance AB, so we take it like this. Okay, so we take this distance, so we put it at A, and we draw an arc here. So this point here is point B, so this is point B. Okay, so then, so we take A1C2, A1C2, so A1C2, so this is A1C2, which is the true length of AC. So put the pinpoint at A here, and we make an arc here. Okay, then we also take B1C3, so B1C3, so which is the true length of BC, so we extend it to C3. Okay, so here, then I will put it, the pinpoint at B, and then I will make an arc here. Okay, so this point is point C, so we call it point C. So now, so I'm going to join the 3 points together. So here we join this together, and then so we join this together. So this shape that we have obtained is the true shape of the triangular lamina. Okay, so now the next thing that we are going to do is that we are asked to measure and state the length of the sides of the true shape of the triangular lamina. So here we have what? We have AB. So we have AB. So this is AB. Okay, so it's equal to. Then we have what? We have BC. So BC on the true shape, so it's equal to. Then we have what? We have AC. So we have AC. So it's equal to. Now let's take the measurement and see what we are going to get. So for AB, I have this to be, so I have this to be 72, so 72. So AB is 72, so I have 72. So plus or minus, you have to write plus or minus. This is how we do state it in technical drawing. So plus or minus 1, so you state like that. Then what about BC? So if I take this measurement from here, so BC, so looking at this, so BC, I have this to be 60, sorry, so this is 68, so BC is 68, so I have 68, so 68, so plus or minus 1, 68 plus or minus 1, then AC, so AC, so I take a measurement of AC from here, so we have this to be 40, so this is 47, so I have this to be 47, so 47, so plus or minus 1, 47 plus or minus 1. So this is the first method, and what we are asked to do, we have done it. We produce the true shape, and also we take the measurement of the length or side of the true shape of the triangular lamina. So thank you, and God bless you. Let's meet on the method 2.